This problem is called fencing a region, and it is problem number 25. So let's go ahead and read the problem in the book and see how to solve it. A farmer plans to use 180 feet of fencing to enclose a rectangular region using part of a straight river bank instead of fencing as one side of the rectangle. And they have a picture in the book. Find the area of the region if the length of the side parallel to the river bank is, and then they give three conditions. So let's just go ahead and try and draw a picture so we can begin to visualize what's going on. So here is like the river, and they're going to build a fence, or use a fence a rectangular region with one side is on the river. Now this is going to be a rectangle, and for all these different scenarios, I'm always going to call the width of this region x. Okay, so for these three different situations, I'm always going to call the width x, therefore this width is also x. Now what do they tell us? They tell us they have 180 feet of fence to use to build this. What does that mean? That means really the perimeter of this enclosure has to equal 180. That's how much fence we have. Now what they want us to do for each of these different scenarios is to figure out how much area we end up with inside our region. So they want us to calculate the area inside this rectangle for the different situations. So for part A, they say that the side across from the river, or they say the side parallel to the river, is twice the length of the adjacent side. So these are called the adjacent sides. So if this length is twice that, then this length is going to be 2x. And now I'm going to use this information about the perimeter to actually solve for x, because once I know x, then I'll know the width of my rectangle and the length of my rectangle, and then I can calculate the area. So it's sort of a two-step problem. The first step is to find x, because once I know x, then I can find the dimensions of my rectangle, and then I can calculate area, because we know the area of a rectangle is the length times the width. So for this first scenario, the perimeter, which is 180 feet, the perimeter, just add up these three sides. X plus 2x plus x. Just to be clear, I can write it out. But it actually is going to equal 4x. So if I want to solve for x, I divide both sides by 4. So x is 180 divided by 4, and I believe that is going to be 45 feet. So for the first scenario, my width is 45 feet, therefore my length is 2 times the width, my length is 90 feet, and therefore my area, length times width, is 45 times 90, which equals 4,000 50 square feet. So that's for part A, the first scenario. Now, if we go to part B, it says that this side across from the river is 1/2 the length of the adjacent side. In part A, it was twice. Now, if I draw a quick little picture, if these sides are x, now this is going to be 1/2 x. So now if I add up the perimeter, I still have 180 feet of fence, and I have x plus 1/2 x plus x. So 2x plus 1/2 x, I believe, if I can do a little bit of math in my head, I believe that's 5/2 x. So therefore, if I solve for x, multiply both sides by 2/5, and for this situation, the x is going to be 72 feet. So now, if this is my width, then my length is 1/2 of the width, so the length must be 36 feet. So now for this scenario, the area is 72 times 36, and that equals 2,592 feet. All right, now there's one more scenario. Part C. Part C says that the side opposite the river is actually the same length as the other side. So if this is x, this is going to be x. It's going to actually be a square. So now we have our fence is 180 feet, and it has to equal 3x. Therefore, the length of both the width and the length is 60. So the area is just 60 squared, which is 3,600 square feet. And up here, square feet also. All right, so that's a little bit of a story problem involving some geometry.